Hi, welcome back to Leetcode. So in this video, I am going to discuss the second problem from today's weekly contest 511, that is count dominant nodes in a binary tree. So what is the problem statement? Problem statement is that you are given the root of a complete binary tree. A node x is called dominant if its value is equal to the maximum value among all the nodes in the subtree rooted at x. Return the number of dominant nodes in the tree. That means, suppose we actually have one tree. This is tree, right? Something. So now I have to check that how many dominant nodes are there. Okay, in this entire tree. So when actually I will say that this node actually dominant node. So suppose we actually have x. X is the maximum value uh, out of this tree. Okay, so whatever the number actually present in this hierarchy as a parent node, this is a root node. So this node suppose actually have y, this is actually z, this is suppose actually a, this is b, c, d. So if x is greater than y or z or a and b and c and d, if x is value of this root node is greater than equals to what are the values is present in this hierarchy. So it should be greater than equals to y, it should be greater than equals to z, it should be greater than equals to a, it should be greater than equals to b, it should be greater than equals to c, and it should be greater than equals to d, x. Then I can call this node actually a dominant node. So that time our answer will be initially it is 0, now it will be 1, increased by 1. I have to count that how many nodes actually are there, such nodes are actually there. Suppose this node actually dominant node. Suppose now I want to check that this node actually dominant node or not. So how actually check that? So this root node value is y, correct? And what is actually nodes present in this hierarchy, that is y, a and b. Three nodes actually present here. Actually you can say that one node, this second node, this is the third node in this hierarchy. Same hierarchy. Hierarchy means below of the current root node. Okay. So this y value should be greater than equals to all of this. It should be greater than equals to y. Anyway, it always true. And it should be greater than equals to a. It should be greater than equals to b. This is clear. If actually it is actually this condition actually it is valid, then actually I will actually say that this node, the y is a dominant node. Then actually our answer will be increased by 1. If it is true. If it is not true, then actually this is not a valid dominant node. So I'll go to the other nodes. Actually, I'll check for the other nodes. Got it? So one thing actually clear that I actually have one tree. Now I have to check that whatever the if I actually current node actually this, the current root node is present pointing here. So somehow I have to know that whatever the actually nodes present in this hierarchy below the hierarchy below this current node, current root node, I have to know what is actually the maximum value present in this hierarchy. Okay. So if whatever the maximum value I have seen in this hierarchy, suppose y, what the maximum value I have seen, and this current node value is x. If x is greater than equals to y, then actually I can say that this will be a dominant node and our answer will be increased by 1. Correct? So in any level or for any node, currently I am pointing here, I have to know that what are the nodes present in this hierarchy or below of this current node. So what are the maximum value I have seen? What are the maximum value? Why actually I have to know only the maximum value, not all the values are present in this hierarchy? Because if whatever the maximum value I have seen here, suppose this is actually z and this is a. If maximum value and maximum value of this hierarchy is z, okay. If a is greater than equals to z, that means it is actually the current node value a is greater than for other also. Suppose z2, a should be greater than equals to z3, a should be greater than equals to z4. Got it? Why actually I am considering only the maximum value, not all the values? Because if I have to consider only about that, only if the current root node value is greater than equals to all the value present in this hierarchy. So if the current root value is greater than equals to the maximum value, then anyways it should be greater than equals to for all the, this condition is valid for all the other nodes also, right? Whatever the actually nodes is present in this hierarchy, same hierarchy. Got it? So let's consider one more thing. Let's just take one example. So this is suppose 2. Okay, this is 1, this is 2, this is 0. Okay, so this is suppose our binary tree. Okay, now I have to know that this node actually is a dominant node or not. Initially our answer will be 0. Okay, so for this node, is there any child? So what is the maximum value I can actually have in this hierarchy? That is 0 only, because for the left child there is null, for the right child there is a null. So that means there is no child. So that means our maximum value I have present in this hierarchy, that is suppose 0. Okay, and current root node value is also 0. So 0 is greater than to 0. Yes, that's true. That means this is actually a dominant node. So our answer will be increased by 1. Correct. Next, suppose to know that this node actually a dominant node or not. So this 2. So what is the maximum value is present in this hierarchy? That is, so first of all, don't consider about the maximum value, consider all the values. So what are the values is present in this hierarchy? That is 0 only, right? And what is the root node value? That is 2. So 2 is greater than to 0. Yes, this is true. So that means this, what are the maximum, this root node value, that is greater than equals to for all the values present in this hierarchy. So what is the hierarchy? Hierarchy is, this is the hierarchy. Correct? Clear? So this is also dominant node. So this, our answer will be increased by 1. Now it is 2. Clear? Now I have to know this node. This is a dominant node or not. So there is no child for this node 1. That's why so current root node value is 1, and also what are the maximum value I have seen, that is 1 only. Okay, so this is also true. So this is all valid. So this is also a dominant node. So our answer will be, our count will be increased by 1. Now it is 3. Clear? Now suppose I want to know that this node 2, this node 2 is actually a dominant node or not. So how to know that? So what is actually values present in this hierarchy? That is 1, another is this 2, and this is 0. These 3 nodes actually present as a child of this node 2. Clear? And the current root node value is 2. Right? So what is the condition to be a dominant node? The condition is that what are the value present in this root node, that should be greater than or equal to for all the values. What are the values or nodes present in this hierarchy? So I know that the values of all the nodes that is present in this hierarchy, that is 1, 2, and another is 0. Okay, and current node value is actually 2. So it should be greater than or equal to for all the values, right? So that means 2 should be greater than or equal to 1, 2 should be greater than or equal to 2, 2 should be greater than or equal to 0. Yes, these 3 conditions all are actually true, valid. So that's why this is also a dominant node. So our answer will be increased by 1. Now it is 4. So clear why it is 4? Now let's take the example 1 from the actually the problem. So this is actually the 538 2471 2471. Okay, now I want to know that this node actually is a dominant node or not. Okay, so so there is no child for this node, so this will be always true. Why? Because the 2 greater than or equal to 2. That's why. Correct? So our answer will be now 2, 1. Correct? Next, this 4, this is also 4, 7. So our answer will be now 2. This 7 also, it is true. This is also dominant node. Sorry, this will be now 3. Just see actually how it is the problem is I am trying to solve. Next is this one is also, this is also true. This is a dominant node, so this count will be now 4. Okay, now I want to know that this 3 is actually a dominant node or not. So what is the maximum value I have seen? So I have already explained why I do not need to consider all the values present in this hierarchy. I need to consider about the what is the maximum value I have seen in this hierarchy. Correct? So what is the maximum value I have seen? So from left hierarchy I have seen 2, from the right hierarchy I have seen maximum value as 4. Okay. Now, so what is the maximum value out of all of this? Out of all of this, current root probability is 3. From left hierarchy I got the maximum value I have seen, that is 2. From the right hierarchy I have seen as 4, maximum value as 4, and the current value 3. So out of this, what is the maximum value? 4. Clear? So that means for this hierarchy, what is the maximum value? That is 4. Clear? 4. And what is the root node value? That is 3. Is 3 greater than or equal to 4? No. So that means this is not a dominant node. Got it? Now go to the next parent. So parent of this root node, it will be now 5. And what is the maximum value I have seen in this entire hierarchy? 4. Clear? Why actually I am returning only 4? Because I need to check only with the maximum value. If it is greater than or equal to maximum value, that means it is valid for all the other values, because all are actually smaller than equals to the current maximum value. Clear? So similarly for right hierarchy also, this is the maximum value I have seen 7. What is the maximum value I have seen here? Actually it is 1. Got it? So that means for this hierarchy, what is the maximum value I have? That is 8, 7 and 1. So what is the maximum value? That is 8. And current root node value, that is 8. So 8 is greater than or equal to 8. Current root node value is actually 8. That should be greater than or equal to what is the maximum value I have seen in this hierarchy, that is 8. So 8 greater than or equal to 8, that is true. That means this is a dominant node. Got it? Why actually I am considering this node 8 as a dominant node? Got it? So our answer will be increased by 1. Now it is 5. So I am going to the parent of this current node. So what actually I have to return? I have to return them 8. Why actually I have to return 8? Because that is the maximum value present in this hierarchy. So that's why I'll return what are the maximum values present. This is 8. Got it? Now for this node, so what is the from the left side, what is the maximum I have seen? That is 4. And from the right side, what is the maximum I have seen? That is 8. So out of all of these 3, what is the maximum value? That is 4, 5 and 8. That is maximum value present in this hierarchy, that is 8. Is this the root node value is 5. 5 is greater than or equal to 8? No. So this is not a dominant node. Got it? So ultimately our final answer, it will be 5. Clear? Let's see. This the expected output, it is 5. Clear? I hope this is clear, the explanation, the process. Now how actually I can solve this? So to solve this problem, somehow for any hierarchy, so I have to do the bottom up approach. Why actually I need to bottom up approach? Because if I want to consider this node as a dominant node or not, it depends on that what are the maximum value I have seen from the left hand side and from the right hand side, right subtree or left subtree. Clear? So that's why I have to do the bottom approach to know that what is the tail max and what is the right max or max. Got it? So I have to solve bottom up. So first of all, I will check that this node actually is a dominant node or not. This node actually dominant node. Then actually I will go to the upward, this parent node, and I'll check that okay, this node actually dominant node is possible. And then actually I go to the parent of this and I'll check that this node actually a dominant node or not. Got it? So that's a simple traversal is need. So we have to first go to actually the left subtree and right subtree. Then actually we have to consider the current node. Got it? So this is kind of recursive approach, right? Because from this current node, I'll go to the left hand side and I'll check that what is the maximum value and return that. Got it? Similarly for the right hand side, I'll go to the right of this and bottom of this, reach the bottom of this and return what is the maximum value I have seen. Got it? And then ultimately consider this current node, whatever actually I am pointing currently, that can be a possible dominant node or not. So now it will go to the code, then it will be more easy to understand. So initially our answer will be 0. So there is no dominant node. And I will call this helper function, which will pass the root node and answer variable. Ultimately, whatever this helper function will calculate that how many dominant nodes are there in this hierarchy or in this tree, and ultimately return that answer. Okay, so how to be solving this through this function helper? So I'll check that this node actually, whatever currently I actually have, that actually leaf level node or not. Leaf level node means there is no left child and right child. That means we can't take any decision that what is the maximum value in the left hand subtree and the right subtree. So that's why for that case, anyway this will be a dominant node, because the whatever the current node value, that is the maximum value. So that's why I'll check that whatever the, if left subtree is also null and the right child is also null, that means this is a leaf level node, and increase our answer by 1 and return the this current node value. Why am I returning this? Because suppose currently I am currently on node 7. Okay, so I have to, first of all I know that this is a dominant node. I'll actually count this as an answer, and before returning I have to return this to the parent of this node 8. So 8, what should actually information I should return? That will be the what is the maximum value I have seen. So what is the maximum value I have seen? That is 7, because there is only one element. I don't need to consider other elements. So that's why I will return whatever the value which is present in this current node value. Okay, I return that. Got it? This is for leaf level node. Okay, suppose there is a intermediate node, something kind of node 8. I am currently pointing the root node. This root node is pointing at node 8. Got it? That time I have to know first what is the left maximum value present in the left subtree, and what is the right maximum value present in the right subtree. Got it? So that's why recursively I will check first of all that if there is some subtree in the left side. So that's why I have to check that if the left pointer is not null, that means we have some element in the left subtree. So first of all, do the calculation for that and return me whatever the maximum value present in the left subtree. So that's why I will call this helper function again recursively and pass the left node. Got it? Root left and answer. And if there is no left child, so that time the left maximum will be the current node value, because I don't need to consider what are the maximum values present. Okay, so that's why I'll consider the what of the current node value, that will be our left max. Got it? Similarly for right max also I need to know what is the maximum value present in the right subtree. So that's why I'll check that first, same way that the right pointer is not null or not. So if it is not null, I'll call this helper function again, pass the right node as a pointer and answer variable. This answer I am passing as a global to count all the actual nodes as a global actually. And if there is no right subtree, so that time I'll consider the current root node value as the right max. Okay, so for this I need to, if I want to know that this 8 actually is a dominant node, what is the condition? First of all, I have to know that this 8 should be greater than or equal to all the value present in this hierarchy. That means 8 should be greater than or equal to 7, 8 should be greater than or equal to 1, and 8 should be greater than or equal to current value. So that's why I'll consider the maximum value of left subtree and right subtree. Got it? So I'll store into the max. Got it? Similar way, I will actually consider the current root node value as the max in the max. So this max ultimately in this two line is consider what is the ultimate max value. This first max value will give me the what is the maximum value out of this considering by left subtree and right subtree. Got it? So I'll store this into the max. Then current max, whatever actually left subtree and right subtree, and consider what the current root node value. So this ultimately store what is the ultimate maximum value. Current root node value, left subtree maximum value, right subtree maximum value. Got it? I have to consider these three only. So I'll see that what are the current root node value is equal to the current max. Then actually I'll consider the answer plus plus. Why actually I'm considering the checking this condition? They mention that this subtree rooted at current node x, that will be a dominant node if only if the current root node value is the maximum value. So that's why this max is the ultimate maximum value of this current subtree or current hierarchy or current tree. So I'll see that maximum value is equal to the current root node value. Then only this will be a dominant node. So that's why we'll increase our answer. If it is not same, then this current node is not a dominant node. So I'll not count and just return them what are the maximum value present in this current subtree. Got it? Because for next I have to consider I have to calculate for the node 5. For that information I need to return that 8 is the maximum value present in this right subtree. So that's why I'll return this max, because in future in parent or the upward side we may get actually some answers. So that's why I have to return the correct maximum value present in this current hierarchy. Got it? So for this, what is the time velocity? Here actually you can say that I am traversing one node at most only once. So if there is n nodes in the entire hierarchy, in the entire graph or entire tree, so it will take big of n. And space only for the stack trace it can go up to maximum recursive stack maximum, and this is constant space big of 1. I hope this is clear, and I have shared this in the description. You can check that. If you like the experience, please like the video, and if you're not subscribed, please subscribe the channel. Thank you. See you in the next video. Bye bye.